constantly looking for the nearest bathroom? Do you wake up multiple times a night to use the bathroom? Right now, Perfect Prostate is sending out free bottles of their groundbreaking new formula to listeners of this station. Perfect Prostate Formula was developed by medical doctor Mitchell Fleischer, and its ingredients have been clinically studied to reduce your frequent nighttime bathroom visits and promote healthy urine flow. Right now, preferred customers get their first bottle of Perfect Prostate absolutely free. There's nothing to lose. Perfect Prostate is guaranteed to reduce that constant urge to use the bathroom, especially at night, and promote healthy urine flow. Don't wait. Call now for your free bottle. Just pay shipping and processing. Dial 1-800-675-0251. That's 1-800-675-0251. Supplies are limited. One free bottle per household. Call now. Dial 1-800-675-0251. That's 1-800-675-0251.
All writers are prone to becoming so attached to our characters and stories that we struggle to see why a passage may not be working. It takes another set of eyes to help us nurture our writing to full maturity. At Black Wolf Editorial Services, we strive to enable writers to develop and grow, shaping stories into masterpieces that can stand the test of time. Editing services are provided for all genres and all age categories. Services range from the critique of the short story through to line edits on full-length novels. We also offer assistance on generating writers' bios for your websites. We won't abandon you to the masses. We want to celebrate with you in your successes. Black Wolf Editorial Services, nurturing your writing into maturity. For a full list of services and prices, visit us at blackwolfeditorial.com.
As a mother, you don't want to have to worry about this bill is coming, but then she needs this chemo. That's a decision you shouldn't have to make.
At St. Jude, a family never sees a bill at all. It's like the world has been lifted off of your shoulders.
The treatment doesn't get any better than what you receive at St. Jude. It saved my life. It saved my daughter's life. It saved our family.
St. Jude Children's Research Hospital. Finding cures. Saving children. Learn more at stjude.org.
The world around us is an amazing place, filled with beauty and with science. But let's face it, sometimes the science can be so confusing that it takes a PhD to understand it. Well, you're in luck. I just happen to have a PhD. Come and take a seat. Perhaps I can explain the world around us in a way we all can understand. Welcome to Conversations in Science. I'm Dr. Judy L. Moore. Call me Doc. Hi, and welcome to a new episode of Conversations in Science. I am Dr. Judy L. Moore, and as my intro says, I do have a PhD. For those of you who are new to the show, the way it works, I do my best to keep the science down to the bare basic minimums so you can all understand, but I have a little helper here to help make sure that I don't go over the top. Jessie, where are you?
I'm right here, Doc.
Hi, Jessie. Right. Jessie, today's topic, we are talking about global warming and climate change, but this is a requested topic. Can you give me a bit of a background as to why we are talking about this today?
All right. You know, we have a lot of different characters around the radio station. Around KLRNRadio. Come on, we got some interesting cats around there.
We do.
Well, there's been discussion, debate, sometimes heated, sometimes verbal, sometimes direct message. Is global warming or climate change real? Is it just weather? Do we need to do anything about it? And the debate has raged for years. And I tried to do some research on my own, Doc. I really did. But I just couldn't figure it all out. It was too much scientific mumbo-jumbo.
Well, I will gladly go through and admit, while I was doing preparation for this particular episode, I was reading a technical paper from the American Meteorological Society. I fell asleep. It was so boring to read. And so I can understand if anybody else is going, oh, it's far too much techno-mumbo-jumbo. So if I fall asleep and I understand it, yeah, no, it's not good. Not good.
Well, I don't think we're going to let them fall asleep today, are we, Doc?
No, we're not. No, we're not.
Because we're not going to be some 100-page research paper.
No, we're dissecting those 100-page research papers and putting it in a way that we all can understand.
Yay,
So,
Doc.
Okay, so I suppose your first question is...
Okay, global warming, climate change, A, what do you think is the right name for it? And B, is it real?
Okay, let's start with is it real? Well, it's very real. It's not made-up science. It is real science. In fact, it's science that we've known about for over 100 years.
Whoa, Doc, 100 years.
Over 100 years, yes. In 1896, Svante Arrhenius, who was a Swedish scientist, had actually gone through and proposed the idea that fossil fuel combustion was going to enhance our natural global warming systems. The Earth has got an average surface temperature of 15 degrees C. That is, if I do my quick little calculations here, 15 degrees C is about 59, 60, somewhere in there, of Fahrenheit. Okay. Basically, without the natural greenhouse gases that are in the atmosphere, and we're talking things like water, carbon dioxide, we are talking methane, we are talking some of these other gases. If they are not there, then we would have a surface temperature of about 18 degrees negative, minus 18 degrees C, which is just
cold.
Below zero on Fahrenheit. It works out to be a minus 0.4 degrees Fahrenheit. I don't care if you're talking about Celsius or Fahrenheit. That's cold. That's very cold.
I'm with you, Doc. I'm with you.
So we need these gases that are in our atmosphere just for life to exist on this planet as we know it. Otherwise, we would all freeze to death.
No, thanks. Don't want to freeze to death. I love my blanket, but I don't want to have to wear it all the time.
Yeah, exactly. But these gases are natural process. It's part of, the oxygen exchange with the carbon dioxide exchange. It is part of the breakdown of ozone, which is a natural thing. It is the methane is all natural. It needs to be there. Decomposition processes actually make methane. It's all natural. It needs to be there. The question really is how much is we as humans are influencing this natural process? How much have we upset that natural balance? And it really is, that's basically what this really comes down to. It is real science. It is really there.
Okay, so Doc.
Yes?
The science is real. This isn't just something Al Gore cooked up in his basement.
No. In fact, I went through and said that in 1896, Svante Arrhenius had actually proposed the ideas. In fact, what he was trying to do in his research is he was trying to find out how much carbon dioxide is linked to the ice ages. If we had too much carbon dioxide in the air, would we go into another ice age? His theories were not confirmed until 1987. So it took a good almost 100 years before his theories could be confirmed. But what happened is back in the, we're talking the turn of the century, the turn of the 1900s, his ideas were just forgotten and considered insignificant. Basically, it was believed that the oceans were so large that they would compensate for anything that we as humans could do. So it was believed that the oceans would basically absorb all of the pollution that we as humans put into the air.
Okay, so the oceans are supposed to be big natural sponges and clean up after our mess.
That's what people believed. Okay. And to a certain extent, that is what the oceans do. Problem is we have saturated the oceans. They can't cope anymore.
Okay, so we've overused that sponge.
We have definitely overused that sponge. If you look at a marine biologist, what was that, Jess?
And you definitely can't. This isn't a sponge you can go out and replace. So how do we clean it up?
Yeah, well, that's what they're looking into. They're looking at various different things to do the cleanup. I mean, marine biologists will go through and say that because of the various different changes that are happening within our marine environments, that we have lost some of the diversity that we have. We've got coral reefs that are dying left, right, and center. We've got plankton that's at risk, and most of the ocean life revolves around plankton. And if plankton's gone, we've got big problems there. Most people will quite happily agree that the marine biologists have done their job. They've proven to us that beyond a shadow of a doubt, there's a problem.
Okay.
However, no one can agree as to how much of that problem is actually mainland issue. You know, oil leaks and stuff like that, it's obvious. It's things that we can see. But things like carbon dioxide in the atmosphere, it's not something that everybody can see, and that's part of the problem. We like things we can see.
Okay, Doc, got a question. If we take carbon dioxide, don't take trees and plants and my little tomato plant sitting out there, doesn't that thing like carbon dioxide to grow and breathe? It likes it and it gives me back oxygen?
It does. It gives, basically, you have this carbon dioxide oxygen exchange. Basically, the plants absorb the carbon dioxide to a certain extent and they exhale oxygen, and then we do the opposite. So there is that balance that goes on. We have this complicated issue in the fact that you have deforestation, so we have less plants, less trees to absorb the carbon dioxide as well. You also add on top of it that we are producing more carbon dioxide than what would normally occur just by using our fuel combustion, our fossil fuel combustions.
Okay.
It's going out there.
I was right on the way it works. It's just we're producing more than we have trees to gobble up.
Exactly. We've offset that balance. That balance is now just not coping anymore because there's just too much for it to cope.
Okay, but I was right that trees and plants like the carbon dioxide.
Mm-hmm. And of course, yes, the oceans have been absorbing the carbon dioxide out of the air as well. But what's happening there is carbon dioxide, when you mix it with water, is carbonic acid. Our oceans are naturally what we call basic. Basic means it's not acidic, it's the opposite of acidic. It's on the other side of neutral. And what's happening is we are throwing in acid into the oceans effectively by putting in the carbon dioxide. So we're offsetting the balance, the acidity level balances of the oceans. And the marine life is just not coping. It just doesn't like it.
Okay, so let me see if I got this straight. There's basic, neutral, and acid. And yes. The ocean likes to be over on the basic side of things. So it likes to be more or less a friendly type of product.
It's not really a friendly. It's still caustic. It still will erode things, but it doesn't in a different way. Marine life has evolved to accommodate that caustic situation.
Okay, so the marine life was happy with the basic situation that was. And then we come along and add more and more and more carbon dioxide to it than it's used to.
Yes.
And so we're adding carbonic acid. Now, how nasty of an acid is that one? That's an acid I'd never heard of, Doc.
Okay. Carbonic acid is what we call a weak acid. It's actually not very strong, but it does have a range of acidity when it's mixed with various different solutions of water.
Okay,
in some cases, it can be quite strong acid, but in some cases, it can be quite a weak acid. It's got a range.
Well, they all have ranges, Doc. They all have ranges. But now, let me see if we discussed a little bit of this off air because I was totally confused first time around, guys. I will admit that. You put too much acid into any base thing, and it's going to make it more acidy. So we've dumped so much carbon dioxide in that the ocean is changing. Now, it hasn't made a huge change, but it's just enough to upset the balance, right?
Exactly. Exactly. That balance has been completely upset, and marine life is suffering because of it.
So what are the effects on the poor little crabs and lobsters and fishies?
Well, what's happening is that their shells of the crabs and other shellfish are getting thinner because the acid that's in their water is actually eating away at their shells. It's taking away that shell. And they're becoming vulnerable.
Okay.
Of course, all the fish that eat the crabs and the shellfish are going, yum, choo, 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 and they're sort of over-engorging themselves, and as a consequence, you have less of it to eat, and it's just a rippling effect. One thing goes, everything else is going to go right behind it. It's going to take time, but it will go.
Okay, so basically the crabs and stuff in the ocean are becoming soft-shell crabs.
They are.
All right, well, while soft-shell crabs are nice to eat, we don't want the whole ocean to be filled with them, do we, Doc?
No, we don't. And it's the same with the coral reefs. The coral reefs are becoming so weak that, just a little bit of a storm in the sea is just destroying the habitat. It's just gone. There are reasons why we're putting things like sunken ships, when we've cleaned the ship and we're putting in false coral reefs, there are reasons why we're doing this. And one of the is to try to combat the dying coral reef problem. We're trying to reinforce those coral reefs as much as we can. It's not going to be one solution to fix these problems.
Well, unfortunately, the U.S. Navy recently ran aground on a coral reef, so I'm sure that didn't help anything.
No, that would not have helped in any way, shape, or form.
Yeah, it was anchored off Japan, and some storm shoved it into a coral reef. So, and there was some 1,100 gallons of unaccounted for hydraulic oil added to our ocean.
Oh, no. Okay, cleanup operations, here we come. Yeah.
They can't even find this stuff to know where it drifted to figure out where to start last I read, Doc.
Oh dear. Marine biologists are probably going absolutely ballistic over this one, but that's fine. We'll cope, I hope.
We'll let them figure out where it is, and then I'm sure somebody will have a solution.
Yeah. Right, so carrying on though, one of the questions, and this is the biggest thing that I suppose has hit the foreground, is how much of this is actually man-made. Again, I've said it before, ocean spills, the oil spills and stuff like that. That's things that we can see. But can we see atmospheric stuff? And most people can't. But I'll give you an example of a man-made problem that we did it to ourselves, people. That is very evident of what we are doing. CFCs, chlorofluorocarbons.
Okay, for a second I thought you were talking cat fur cleaners, Doc.
No, not cat fur cleaners, sorry. Chlorofluorocarbons.
That's a mouthful.
In the 1920s, it is a mouthful, which is why we say CFCs instead. In the 1920s, refrigerants, so the things that were used in refrigerators to keep everything cold, were replaced with CFCs. The reason why they made this replacement was because the refrigerants they were using prior were flammable, they were highly toxic, and systems were leaking, and people were dying as a consequence. So they changed these things to these man-made chemicals, and CFCs are man-made. They are not natural. They don't occur in nature in any way, shape, or form. They are non-toxic, and they are non-flammable.
Well, that sounds like a smart thing if you've got people dying from owning a refrigerator, Doc.
Exactly. CFCs are also supposed to be highly stable, or at least so we thought. Basically, what happened is you have 1920s, refrigerant has been replaced by CFCs. After World War II, you had propellants being replaced by CFCs. So, your bug sprays, your can of hairspray, your asthma inhalers, everything that has like this compressed gas that just needs a sudden burst of a propellant of some sort, that was all CFCs as well. Everything became CFCs.
Okay, So we basically made up this compound called CFC and found 1,000 uses for it, and we thought it was safe.
We thought it was very safe. However, in 1974, so we're talking just shortly before I was born here, it was found that there was an excess amount of inorganic chlorine in the stratosphere. The stratosphere is the layer of the atmosphere where planes fly. It's the layer of the atmosphere where the ozone layer is. It goes for quite a bit of ways. It's about, over the poles, it's about 8 kilometers above the Earth to about 50 kilometers above the Earth. And then, of course, over the equator, it can be around about 16 kilometers. So there's a bit of a range there of how thick that stratosphere is. But that's where the ozone layer is. That's where planes fly. That's where everything tends to happen. It's just
that's the part
above
of the sky
where our
most
weather
of us
is.
are familiar with.
What was that?
That sounds like the part of the sky most of us are familiar with, where the region where planes fly.
It's the regions where planes fly.
So most of us are probably familiar with that region of...
Yeah. So we had an excess amount of inorganic chlorine in the atmosphere, in the stratosphere itself. Now, it was found that what was happening is CFCs break down to their elemental components when exposed to UV radiation.
And of course, we hadn't figured that out before, right?
We didn't know this prior to 1970. We didn't know. And what was happening is all that CFCs that we put into the air from all of our propellants, the refrigerants, everything, CFCs were breaking down, and we suddenly had this chlorine. Now, this is bad news, because what was happening is the chlorine was breaking down our ozone. Ozone is an oxygen compound. It has 3 oxygen molecules, not 2. And what it does is it's the Earth's natural sunscreen against UV radiation.
Oh, cool.
It blocks the UV radiation.
Well, we don't want all the UV radiation. So
no, we don't.
We need ozone, right?
We need ozone. So what was happening is the chlorine was attacking the ozone, so we were getting more UV radiation. And we suddenly had a surgence of skin cancers. We had a surgence of things becoming too, basically burning on the Earth's surface. Things were just going absolutely out of whack. And it all was found in that one discovery of CFCs. So it was a man-made compound. We did it to ourselves.
Okay, so we thought we had something safe. Then about 50 years later, we find out, nope, this stuff's bad news bears, right?
Bad juju. Very bad juju.
Okay,
and
so then what did they do about it?
So in the 1987, you had the Montreal Protocol, it was one of those things that, the Earth Summit type things. 27 nations had signed this document saying that they are going to reduce substances that deplete the ozone layer. One of them was CFCs. As of 2013, CFCs banned worldwide.
So is that why my hairspray no longer has CFCs in it? It has some other propellant substance?
Yes, that's exactly it. It was to get rid of the chlorine.
So what'd they replace it with?
They replaced it with hydrofluorocarbons. So instead of the chlorine, it has hydrogen.
Okay. I assume that's a better thing?
Well, hydrogen's natural.
Okay. Well, if hydrogen's natural, it should be a better substance to be shoving back out into the air.
Yeah.
Every time I do my hair.
Here's hoping.
Yeah, we'll know in 50 years, huh, Doc?
Yeah, we'll know in 50 years. It's one of these things that's just a bit of a confusing thing, because we put all of this stuff up there and people don't realize that we are actually, some of it we are doing to ourselves. Some of it's natural. Some of it, the whole process is there. And it just needs to be there. Ozone. Now here's the thing with ozone. And this is what makes the whole situation completely and utterly confusing. and incredibly complicated. Ozone is a greenhouse gas. The definition of a greenhouse gas is that it absorbs radiation of one form and it will spit it out as heat. Water and carbon dioxide absorb infrared radiation, where ozone absorbs ultraviolet radiation. But again, they still spit it out as heat. But without ozone in the air, we get really bad levels of UV radiation. There are 3 different bands of UV radiation that exist. We have the really, really harmful stuff, which is UVC. That's really short wavelengths of UV radiation. None of it finds the Earth's surface. UVC is filtered out 100% by oxygen and ozone. We don't see it. You have to go outside the Earth's atmosphere to see UVC.
So you got to go up into space by the moon. You got to go play on the moon to find that one, right?
You've got to at least leave the Earth's atmosphere. You've got to go you've got to go above the ozone layer. You've got to go above the stratosphere. So the space telescopes can see UVC.
Okay. So space telescopes can, but humans don't.
Humans don't. Not humans on Earth, anyway. Okay. UVB, which is your middle band, is the form of UV radiation that has actually been linked to skin cancer. Here's the complicated thing. We need UVB to continue to survive because our bodies see UVB and it goes yum, yum, yum and makes vitamin D.
We need that stuff, Doc.
We need vitamin D for our bone health.
I'm always seeing vitamin D served up along with calcium pills.
Yeah, because calcium helps us absorb vitamin D. Yeah.
Okay. So those two like to play together.
Yeah, and we need vitamin D for our bone health. Okay, but yet if we get too much vitamin B, if we get too much UVB, we could get skin cancer.
Well, that's not cool either.
Do you see why this is not a simple issue? Because we need these things, but yet too much of them is a bad thing.
Well, just like I like chocolate, but too much of it will give me a tummy ache.
Exactly. Okay, and the other band of UV radiation is UVA. So that's the really, really short. No, really, really long. Yes, really, really long bands of UV radiation. Almost all of UVA finds the Earth's atmosphere and finds the ground.
What's UVA do?
UVA is attributed to premature aging of skin.
Oh, great. But is UVA helpful?
UVA is helpful because it helps all of our plants grow. If you've got UV lights in your aquariums and your various different plant
my little
greenhouses,
hydroponic garden has a UV light, Doc.
That UV light will be using UVA radiation.
Okay.
It makes everything grow. So we want UVA. UVA good.
Except
mostly.
For our skin.
Except for our skin. It's premature aging. It makes us look old.
All right.
It's a complicated situation, isn't it? It's not simple as people think.
Okay, now, you mentioned that the ozone's thinner at the poles, and you live in New Zealand. So,
yeah, I live incredibly far south.
So
ozone
radiation. Let me see if I remember some of our conversation from before we came on air.
Okay.
All right. So there's an ozone hole over the poles, right?
Yep, there's one over Antarctica and there's another one over the Arctic Circle. Yes.
Okay, now what effect does this have on the humans?
Okay. The effect that these holes have over the humans is that we actually have more exposure to UVB radiation. If you are living in a polar countries, so quite close to these holes, in New Zealand and Australia, South Africa, we are reasonably close to the hole. We get more skin cancers than other parts in the world.
All right.
Because we are getting exposure to that UVB.
Now.
But these holes are natural. They are meant to be there. Basically, to create ozone, so the Earth does have a natural process where it naturally breaks down the ozone and then it naturally makes more. To do that, it needs sunlight. And of course, the poles in winter don't get sun at all. So they're not, so whatever ozone's going to be there is going to naturally deplete. It's going to naturally disappear, and you're going to get a thinning of the ozone layer naturally.
Okay, now you told me something when we first met long time ago, that your kids have to take a hat to school every day.
Yes, yeah, and I think this is in Australia as well. Within New Zealand, we in our term 1 and term 4, so that is our summer months, our summer terms. We have at our schools, especially our primary schools, so that's elementary age school kids, a no hat, no play policy. It is part of their school uniform that they have to have a wide brim hat.
So no baseball caps.
No baseball caps. These hats need to cover the neck. These hats need to cover the ears as well as the face. They are wide brim hats. The idea is that you are sheltering yourself as much as possible from the sun. Kids like to play outside. We shouldn't have to stop them from playing outside.
No, we shouldn't.
So if we cover ourselves, they're not going to be exposed to UVB radiation as much.
I was doing a little research of my own. And
yes?
I think this is an Australian song, but I'll let you hear it. And you can tell me what you think, Doc, because I thought it was cute.
Okay, fire away.
Slip, slop, slap, seek and slide, have fun outside, but don't get fried. Slip on a shirt, slop on sunscreen, slap on a hat, 6 shades, slide on sunnies, simple as that. Slip, slop, slap, seek and slide, have fun outside, but don't get fried. Slip, slop, slap, seek and slide.
Oh my God, that's so cute.
Hey, I do a little research of my own, Doc, and I couldn't resist it. It was just so catchy and cute, and yeah.
It's very similar to the phrase that we have here in New Zealand, but not entirely it's not 100% the same. I mean, they had, what was it? Slip, slop, slap,
seek,
slide.
and slide.
Seek, slide. Okay. Our one is slip, slop, slap, rap.
But it's basically the same principle. So
it is very much the same principle.
So what's slip, slop, slap, rap?
Okay, slip, slop, slap, rap. So you slip on a shirt, slip into some shade, in the heat of the day anyway, slop on some sunscreen, slap on a hat, wrap on some sunnies, where sunnies are sunglasses.
Right. But I just thought that little ditty, I tripped over it. It was so cute. Hey, I think they need a program like that here in this country to remind people to do the same thing.
Yeah, that would probably be a good idea to have that, those little things. They're catchy. They're really catchy. And my children have just never known any different. So when I go through and we're heading out the door and we know we're going somewhere where we're going to be outside, I turn around and I say to my 15-year-old and my 11-year-old, "Where's your hat?" And they're going, "Oh, okay, I'm going in. I'm going to grab it." And they come back out and they've got a hat on. They don't know any different.
So they've grown up with it.
They've grown up with it. And I think that's actually pretty good.
See, I don't like wearing hats. I really just don't like them.
But if you had grown up with it, you would actually just be used to it.
Yeah, I probably would be. But what I do instead, Doc, when I've got to be outside, I always have my sunglasses, or as the little ditty said, sunnies. I think that's such a cute name for them. I always have my sunglasses. I have like 5 pairs of those, so there's never an excuse. And I always make sure I buy the ones that have the UVA and UVB blocking stuff.
Yes, that's a good idea.
Now, what I do is I have a baseball cap I like. Now, it doesn't cover the back of my neck, but before you get started, it's actually got a cloth add-on to it that does cover the back of my neck. So while the baseball cap design doesn't, it's got a cloth running down the back of my neck to cover it.
Yeah, that's good. No, that is good.
But I don't spend that much time outside anyway, Doc. I'm usually at the keyboard.
You know, you're a vampire. We know this. Carrying right along. There was an example with the CFCs and ozone that we as humans were doing it to ourselves.
Right.
Now, the biggest thing is most of our environmental impact that we talk about it in terms of our carbon footprint. We talk about it in terms of carbon dioxide. So there is a big question as to how much influence humans have over the carbon dioxide and how much of an impact carbon dioxide has on what we are talking about, you know, the global warming and the climate change issues. According to our geological records, and then we can go through by looking at ice cores, and they drill into the various different ice shelves and glaciers and all that sort of thing, and looking at the air pockets, you can work out what the atmosphere was like at various different points in history. By looking at this record, we know that during the ice ages, there was approximately 200 parts per million of carbon dioxide in the atmosphere. During the warmer glacial periods between the ice ages, we had approximately 280 parts per million.
Okay, and how many do we have now, Doc?
Here's the thing. In 1950, we surpassed the record. We were over 300 parts per million.
Okay, what's that mean?
We are now, 2017, we are now over 400 parts per million.
Okay, I understand the numbers, but what do they mean, Doc?
What it means is that we have double the amount of carbon dioxide in our atmosphere than what we would have had during the Ice Age. We have 1.5 times the amount of carbon dioxide in our atmosphere than what we had during the glacial periods. These changes occurred industrial age. This is human influence. This is not natural anymore. What that difference is 100% us.
Okay.
We've done it.
Now, my tree in my front yard, doesn't it love carbon dioxide? Isn't that what it breathes?
But it can only breathe so much carbon dioxide.
So
That's why there's actually a slight fluctuation of carbon dioxide in the atmosphere, because the trees will breathe. They will absorb it in during the spring and summer, and then during the fall and winter, they can't cope. And so the atmosphere just has to take it. And then you get this buildup of carbon dioxide during the fall and winter months. You have this buildup. It is a natural process. But the average, the yearly average, it is staying about twice the amount of prehistoric times. That's not good.
So, all right, let me see. I just want to make sure I got this. Because we've talked about a lot of stuff today, Doc, right?
We have.
All right, the ocean is a big sponge, and it absorbs stuff out of the air, and if it was the normal amount, it could cope, but we've surpassed the normal amount, so it's not doing well. Am I right on that much?
Yes, you are right on that much.
Okay. If we were pre-industrial era humans, which, sorry, Doc, I ain't giving up my car and going back to horse and buggy, sorry. But if we were pre-industrial era humans, we'd have about the same amount of carbon dioxide in the air that they did way back when. And so while the plants and stuff love carbon dioxide, we're putting out more than they can eat.
Yeah.
And the ozone holes...
And, of course, there's less plants as well.
Right. And the ozone holes that everyone screams about are actually natural, but we may have made them had some impact on them and made them a little bit worse because of when everybody thought CFCs were the best thing since sliced bread.
Yeah.
All right. And don't forget to put on your sunscreen, your hat, your t-shirt, and your sunnies.
Yeah. Shall we put a little spanner in the works in all of this?
Oh, now what are you going to tell me, Doc?
Okay. Temperatures. Global temperatures. Now, this is the biggest thing at the moment because the Paris Accords, which were signed 2 years ago, are working towards efforts of keeping global warming, so our average surface temperature, to less than 2 degrees more than what it was pre-industrial. There's a few spanners in the works in this. One of them being, no one can agree what pre-industrial was.
Okay, so how can you have a standard? How can you have a standard nobody can agree on?
Yeah, so there's a few questions about that one. There was a report, and this is the one I was reading when I fell asleep. It was a report, it's a 2017, very, very, very new report from the American Meteorological Society that is proposing that we use this time frame of 1720 to the 1800s as pre-industrial. And if we use those as our calculation, then we are now officially 1 degree more than what we were back then. However, I saw another report that says we use a different time frame and we are now only 0.9 degrees more than what we were back then. Different time frame. So that's part of the issue. Now, if you actually look at the temperature records, the average surface temperature for the Earth, after World War II, there was actually a cooling. We were not warming. We were getting colder.
Wait a minute. So everyone that's screaming, global warming, the Earth's warming up. It doesn't always warm up. It changes, but sometimes it cools down. So what happened in World War II? Just after World War II, we had a sudden burst of our industrial products, and we were putting sulfates into the air. Sulfates will reflect the sunlight. They don't absorb it. So as a consequence, it has a cooling effect, not a warming effect. And we had an excess amount of sulfates. Sulfates, though, are not good either. You mix a sulfate with water, and you get sulfuric acid. Ooh, that's a nasty bugger. I've heard of him.
Yeah, that one's a highly acidic bugger. It is not good in any way, shape, or form. It also goes through and affects our quality of our oxygen, and we can't breathe. It is bad news.
That's not good. All right, so let's just pause here for a second. The climate is changing, but it's not always warming. Sometimes it's cooling. So when everyone screams global warming, maybe that's the wrong name?
I think it's the wrong name. I think we should be talking about climate change. And when we're talking about climate change, we're not talking about, we suddenly have more hurricanes or we suddenly have, tsunamis or anything like that. What we're talking about, and I'll give you a perfect example. Ancient Egypt was considered to be quite luscious. The lands around the Nile were farmlands, and it was a gorgeous plateau. Great grasslands. But you look at that region of Earth today, and it's a desert. That's what we're talking about climate change. We're talking about the loss of the ability to produce food. And it can go both ways. You may have lush grasslands that become bogs, and you still can't produce food of any reasonable quantity in a swamp. It doesn't work.
No, maybe rice, but that's about the only thing I think you could grow in a bog.
Exactly. So when you're talking about global change or this climate change, you are talking about this ability or loss of ability to produce food. So climate change is probably a better term than the global warming. The only thing is that the global warming is something we can measure. We can measure it now. These climate change effects that we see is long-term. We're not going to see what we did yesterday for another 10, 15 years yet.
Okay.
If we took steps right today to deal with something, we're not going to see the effects of it for another several years.
Okay, so we may be able to fix some of it, but we can't flip a switch and fix it tomorrow.
No, we can't.
Okay, so let me see if I got this straight. Man has impacted the environment, period. Scientific fact, right?
Scientific fact, all scientists agree.
Okay, we can measure global warming. Now, by what standard, we're not going there, but we can measure the fact that the overall temperature on the Earth has changed, right?
Yes.
All right. And while humans sometimes think they have the answer, we can try something, but we won't know for a decade if it's working.
Yeah.
All right. So, and ozone holes are natural. You just got to wear your sunscreen, your hat, and your sunnies.
And hopefully, some of the initiatives that they're hoping to try to deal with the CFCs will actually help combat that issue and stabilize the natural rhythm for the ozone creation.
Okay, so climate change is a real thing, Doc. It's not just the weather.
Yep. Very real. Very, very, very real. And it is something worth being concerned about.
Okay. Now, I know you said we're going to have to do another show on this. Can you give us a kind of preview about what we're going to talk about in the second episode of this show?
Okay. In the future, we are definitely going to have another episode because there are so many ideas out there about what we should do to fix or to combat some of these issues that we've got with the climate change and the global warming. And some of them are actually pretty good ideas. For example, changing our combustion engines to some other form of engine. That's a very good idea. However, some of them are just Looney Tunes and really they don't quite understand what they're talking about. For example, killing all the cows just to combat the amount of methane. Yeah, no, sorry, that's actually going to create more methane. But that's okay.
Not to mention we'd lose a great and very tasty food source, Doc.
Yeah, we would. So there's a few. So that's basically what we're going to have to talk about, and it's some of these ideas because I know you've come across a few crazy loony ones. I've come across a few crazy loony ones. I've come across some really good ones as well. So we're going to talk about some of the initiatives that people are taking, and whether they're good, whether they're going to have a bad impact, a good impact, what they might do.
Okay, but we'll do that in another episode because guess
not
what,
this
Doc?
one.
We're about out of time.
We are indeed.
All right. So, as we do at the end of every episode, here's where you can find us.
Well, that brings us to an end of another Conversations in Science. If you have any questions about science and about some of the world around us, feel free to drop me a line. I'm on Twitter, and you can find me at Judy L. Moore, or you can look me up on Facebook, Judy L. Moore, or you can drop me a line on my personal website, judylmoore.com. I think you're seeing the pattern here. Then, of course, if you are interested in some of the other projects I do, which is the writing and editing, feel free to check me out on blackwolfeditorial.com. But then, of course, don't forget, if you are wanting more information about the science, you can also contact us at the station with the email of science@klrnradio.com. Then, of course, there's my cohort that keeps going through and popping up.
You mean me, Doc? Well, for anybody who wants to track me down, you can find me on Twitter at Jessie's POV. And you can also drop me a line at the station at Jessie's POV at KLRNRadio.com.
Bye, guys.
Bye.